Great. Okay, so I'm Mike Richter, work for the Bureau of Mines and Geology. I'm also a Big Sky resident, and I'm going to talk about groundwater conditions today in the Big Sky area. I work at the assessment program where we're doing kind of county-wide aquifer characterization and statewide long-term monitoring in Montana. James Rose is going to talk next about the Groundwater Investigations Program, where they look at a more specific and detailed study in a given area, usually involving a computer model. Big thanks to John LaFave for his help with this talk. John's a great presenter. I'm usually out in the field, so I'm a bit more of a wild card. So we'll see how this goes today. Okay, so to look back at the past, here we are in 1993 in Big Sky. So here's where the wells are. This graph is just wells drilled per year. You can see we're kind of just ticking along at about 10 wells being drilled every year. Just kind of a flat graph. Nothing really too exciting going on. Just kind of slow, steady development of the groundwater resource here. Skipping ahead to 2016, you can see we've really kind of filled in the area with wells. And, we've also, we're using wells in the Big Sky area for drinking water. That's what this graph is showing. Domestic and public water supply uses making up the vast majority of these wells. So some people would say in Big Sky, we'll drink anything. We drink a lot of groundwater. So something happened here. I'll do it again. In the early to mid 90s, you can see this graph of wells per year upticks. The slope of this graph changes, and we've kind of never really looked back. So what the heck happened in the mid to early 90s? Well, a lot happened. First thing that happened, river runs through it comes out. Oops. River runs through it because I gave it away. We'll just go right to it. River runs through it happens. Hollywood finds out about Montana. The tram goes in. And Ron Edwards gets hired as the director of the Water Sewer District. Ron comes into a building moratorium and gets that dealt with. The other thing that happened is the notorious exempt well loophole happens as well. So a bunch of factors come together, and we see this not just in Big Sky, but all over Montana, this increase. So looking at Big Sky again, here's all the wells and where we are monitoring on a long-term basis. We've got the green dots are our long-term sites. We've got 12 wells and 3 springs that we monitor in the area on a long-term basis. Most of this data we started collecting in about 2008, so we've got about 8 years of data. Ideally, we'd have about 30 years of data, but slowly but surely, yeah, we're getting there. Okay, so if we look at the general geology in Big Sky, we do have a couple sand and gravel aquifers. These are alluvial aquifers. They're some of our best aquifers. They're really small. If you look at the spatial distribution here, they're making up a small portion of the Big Sky area. So these are sand, gravel, and cobbles that have been eroded from the mountains and deposited into the basins. They're not very big, but they're great aquifers. The green areas, these are sandstone and shale aquifers kind of surrounding the Meadow village. These make decent aquifers, but they're fairly marginal in terms of water quantity and quality. Typically, they have elevated pHs and elevated mineral contents. I think we'll be hearing significantly more about this aquifer type from Pete later on because he's treating a lot of this water at private homes. The blue that shows up is the Madison limestone. Madison limestone's a great aquifer. Unfortunately, in the Big Sky area, it's only available kind of right down at the junction between Highway 64 and 191 and south of Big Sky down near Red Cliff Campground. In the Big Sky area itself, this unit is buried very deeply, just the way the geology is set up here. So it's kind of inaccessible in the main Big Sky area. There's also fractured bedrock aquifers in the Gallatin Canyon, and also up at the mountain village. There's some intrusive dacites that make a decent aquifer where they're connected to the recharge coming off of Lone Peak. So here's what some of the graphs look like from our long-term sites. Again, these are all out there in the GWIC database. One of the things you'll notice looking at most of these graphs is they almost all have a yearly spike in them, and that's the spring runoff event. So snow melt is not just the driving factor in surface water, it's definitely the driving factor in groundwater as well, and we see that in all this data. So let's focus in now on, we're skipping now, we don't have time for that. We're focusing in on what we're calling the Meadow Village Aquifer. We're sitting on top of it right now. It's small, but it's a great aquifer. This aquifer is getting recharged by surface water at its western end and its northwestern end. So where you've got the North Fork coming in and the Middle Fork forming the West Fork and Crail Creek in from the north, these are the main recharge sources for this aquifer. As you move down gradient, eventually the aquifer does become connected to the West Fork. It starts discharging water back into springs and into the stream channel itself. So what we're looking at here in this graph is some hourly water level data from one of our monitoring sites right around the corner here on Spotted Elk Road. So this is kind of a pitch for why we need long-term data. If you just happen to look at this is about 2 years worth of data, it'd be easy to say that we got kind of a bad scenario going here with a downward trend. It looks kind of alarming if you just look at a couple of years. The other thing to note about this well is 49 feet deep, and this is in the deep part of this aquifer. Water levels are varying between about 5 and 15 feet below the ground surface, so this aquifer is vulnerable to surface contamination. It's very close to the surface. Water quality in this aquifer is generally really good, less than 500 milligrams per liter of total dissolved solids, and nitrate values in the deep part of the aquifer between 1 and 2 milligrams per liter. Some of our test sites where we're further out to the fringe of the aquifer where it's only 15 to 20 feet deep and it's underlying the Big Sky Golf Course, there we're seeing nitrate values as high as 5 milligrams per liter, so quite a bit higher. So this aquifer, again, it's not very big. Most of it is only 10 to 30 feet thick. There is a deeper trough just north of the West Fork where this deposit is up to 50 or 60 feet deep. And that's where the Big Sky public water supply wells are. There's 5 wells being utilized by Ron and the Water Sewer District to supply water to the Meadow. So if we go and look at the whole graph, okay, now it doesn't look so bad. It's definitely responding to changes in climate and precipitation and variability in the snowpack, but overall, it's looking pretty good, pretty steady. Okay, so here's our monitoring well on the upper left. So these shaded areas are our spring runoff events showing up in the groundwater. See them every year. It's the biggest driver in the system. But there's another pulse showing up every year that's in red. This is this late summer fall pulse that shows up every year also. That is artificial recharge from the treated effluent being land applied to the golf course and the surrounding pastures. We're seeing it in the well data every year. Sorry, skipped ahead. The other thing, if you look right at the end of this graph, something different is happening. You can see it, something we haven't seen before. And what that is July, so this summer, this new public water supply well goes online and begins pumping. So again, this is hourly data. We've just zoomed in on this summer, which actually, the other thing to point out is you can do this now in GWIC. In the GWIC database, you'll see this slider bar at the bottom of the graph. If you're on a hydrograph now in GWIC, you can slide this bar over and it will zoom in to whichever data you're interested in looking at in these graphs. This came online about a month ago, and it's pretty slick. So yeah, you can zoom in on things without actually downloading all the data and exporting it to Excel. So it's great that we have 8 years of background data on this aquifer, because we have entered into a new amount of groundwater withdrawal from this Meadow Village aquifer. So it'll be interesting to see what happens in the future. We're watching it. So takeaway points are that the Meadow Village aquifer here, it's one of Big Sky's best. It's highly productive. It's small. It's vulnerable. It is connected to the West Fork, and it is the main source of water for the Big Sky Meadow. And groundwater conditions are really variable in Big Sky. And also long-term monitoring, we started in 2008. And we are going to continue this monitoring. So while sometimes it looks like I'm slightly unorganized in terms of long-term monitoring, don't worry, I got this. All right, James, it's all you.
John and Mike came in here in 2008 and got a kind of an overview of what's going on in the area as far as groundwater availability and what resources were being used. Our job in the Groundwater Investigation Program is to come in and do a much more specific study, and our specific assignment was what water is available up here, what are the issues that are going on, and what's the plan for the future as far as how much capacity can the existing aquifers supply to the area, and what are some options and alternatives for some of the dealing with some of the expected growth. And so with Mike's information and John's, we took inventories, which means we visited a number of wells in the area and collected water quality information such as pH and specific conductance. We collected water samples from some of the wells. We monitored water levels. We figured out what aquifer these wells are in. And so between what Mike had collected and I collected, we went to about 115 wells. And I want to thank a number of people in here, Ron especially, and Kevin Germain and John Olson and Eric Butts, Mike and Rich Chambers from Yellowstone Club. With their help, we were able to get to many wells throughout the entire resort area. So this is going to give us a great picture overall of what's going on. And I think that's very important to know because it's all the hills and slopes we have around here. There's a great deal of structure involved in this area. So even though there's a number of aquifers being used, these aquifers themselves are actually broken up and separated by some of the structure too. So that's kind of significant in what's available for water supplies. So again, we got a good view of wells all around the entire area, and we were able to monitor a number of these. So we picked about, and the other thing we did was, as I mentioned, we picked out the geology of the area, and this is kind of a nice little 3D view of what's going on. And all the green is Cretaceous sediments. That's those shales and sandstones that Mike talked about, and they're less than ideal in most cases for productivity, and they're also a lot of times highly mineralized with iron, sulfur, things like that. And I think you notice that in some of the wells that are drilled around here. There's also the PPMS down the lower right corner of the image here. That's the Madison limestone. That's a very popular aquifer around Montana. But unfortunately, like Mike mentioned, although you can see the palisades of them up here, right below Meadow Village area, it's about 4,000 feet to the Madison. And there's a lot of questions about, there should be some good water availability, but there's also questions about quality. There might be a water quality issue. It may not be ideal water down there. But a 4,000-foot well is extremely expensive. Most wells are less than 600-700 feet deep. So a water well of that depth would be a major undertaking. In cross-section view, just looking from Lone Peak down to the Gallatin River, right through the Meadow Village area, just get an idea of the sloping and tilting of some of these layers. And all the greens colors are those Cretaceous layers, and many of the wells are drilled into those formations in order to draw the water for the different areas around the resort. And the red is that intrusive that forms Lone Peak. It's the dacite. It's kind of igneous, sort of a granitic style type of rock. And on the surface, you see it's highly fractured. and that makes a great water reservoir. All those fractures, you can drill into those with a well and draw water, but as you go deeper, it's less fractured and less broken up, and so you're not able to get water. It's not just a matter of just going anywhere in that formation and getting some good water, but up at the mountain and up at higher elevations where it's more exposed at the surface, it becomes a good water reservoir. Also, when that intrusive came in, it went into a lot of these shales and sandstones, and it baked those units, and it sealed up all the pore spaces in there. And so a lot of places, some of these sandstones and these shales are not open and permeable to water because of this alteration that they've gone under. So looking at all those well inventories that we collected and looking at the geology of the area, we came up with about 9 aquifers that are actually being used by wells in this area. So that's quite a few. And again, these upper level ones, the dayside intrusives, that granitic rock of the Lone Mountain, Frontier, Mowry, Muddy, Thermopolis, and Kootenai are all sort of the shales and sandstones. Kootenai is one of the better quality aquifers in the area, but in some places it's too deep or it's not present in some places either. And then out around the margins, like Mike mentioned, you have the Madison limestone down by the canyon, and some of the basement rock, which is the rock to the north of Spanish Peak Mountains, and that area is all the granitic rock, and there's a few wells in that, and again, getting water out of fractures. So we also monitored a number of these wells. We picked I think about 65 wells. We monitored water levels throughout the year. We collected water samples from these wells, and also we put transducers in some of these for the water levels, so hourly readings throughout the year. And so we got a good coverage, tried to get into all the different aquifers and all the different parts of the resort area. And so we've got this really good data collection now. We also looked at some isotopes of water for age dating and trying to figure out what the connections are between some of these aquifers and some of these water systems. And we'll have an idea of where the qualities vary and what the differences are across the area. So we also monitored surface water, because in almost all these studies that we take on, you always find that there's some sort of surface water, groundwater connection. So we monitored about 15 sites for stream flows, and we also collected water samples during high flows, during low flows, and during those transition phases, like the end of the runoff period through June and July. Excuse me. So we've got a number of water sample information and water flow information for a lot of these, especially the West Fork through the aquifer, Meadow Village aquifer that Mike had talked about. So just to give you an example, that surface water groundwater connection, here's the Meadow Village aquifer. The golf course is within that yellow circle, and that's pretty much the extent of this aquifer we're standing on right now. It's about 2 square miles, sand and gravel fill over a hard shale that's fairly impermeable to water. And the red dots are a lot of the wells and yellow dots are wells that we've monitored that are already in the system. And then the triangles are stream gauges. So we have surveyed all these elevations, and we know very precisely what the elevations of these are. And look at the red circle there. I wanted to show you the water level measurements we monitored over the last year and a half. So the blue line is the stream elevation, and the red line is the water level in the well next to the creek. And you can see that the stream is at a higher elevation than in the groundwater, so that suggests that the surface water is recharging into the groundwater at this location. The gray line represents a well farther into the sand and gravel aquifer, and you don't see as much. You see some response to the surface water recharge. And I think that first big jump that takes there is that March period when things warmed up this year, had a lot of snow melt down low. And then some of those peaks are probably some of the irrigation periods. We got to look into that and kind of figure out what might be going on, but that could be some recharge reaching into the aquifer below the pasture land. But anyway, I just wanted to show here that the stream level is higher than the well water levels, and so you're getting water flowing from the stream into the aquifer. A little farther down, the next red circle, that's at the Trail Ranch Homestead area. Again, we have 2 wells, a deep and a shallow well, and we have the staff gauge there. And at that site, you can see now that the stream level is below the level of the well water. So it suggests there that the groundwater is discharging into the stream at that point. So you have a lot of exchange going on into and out of. So it's all interconnected system. And we're going to use a lot of this information for some of our work that's coming up this winter and figure out exactly how much is going on here and what kind of things we're seeing along the whole stretch of the river. And we're doing that for all those other wells I monitored as well. We're also looking at the surface water, groundwater connection that might possibly be occurring throughout the resort area. So as Mike mentioned, there's 5 wells here that Ron operates for the water supply system. And again, you notice they're on the north side of the golf course area. The creek runs that brushy area down through the middle is the West Fork Creek. The little black symbol there's the clubhouse area. And we're down here by the ponds on the right side of the image. And what I outlined here is roughly the extent of the groundwater that's in the system. You'll notice to the south through Town Center and Firelight Basin, that's still the sand and gravel aquifer, but there's quite an elevation gain there, and the sand and gravel gets quite thin, and there really isn't any water available in that part of the aquifer. So you're dealing with everything essentially from the highway and the new hospital and grocery store to the north, and that's pretty much the aquifer that's available for use. So when I came in to do the monitoring here, we had these wells that Mike had been monitoring over time. These are some older wells within the golf course area, but you can see there's a big blank area off to the west and the south as far as no wells drilled through that area to see what's the nature of the aquifer in that area. And Ron in particular is interested in extending possible additional public water supply wells off to the west in this aquifer to see, they might add some additional capacity to the system. So what we did was we came in and we drilled 15 more wells to get more definition. We drilled down to the shale beneath the aquifer to give us a depth. Then we also monitored water levels in all these wells through the last year, and we've also collected water samples. And you can see I've got 2 wells down on the south side next to the grocery store and the hospital. And again, like I mentioned, the one's sometimes got water in it and most of the time dry, and the other one's been dry almost the entire year. So with that information, we were able to contour the depths of this aquifer, and this is going to be great for our groundwater model we're going to develop over the winter. And Kirk Warren is I'm working with Kirk on this project, and he's going to develop this model and use this information to define that basin and that volume of the actual volume of the aquifer. And you can see how it thins out quite thin along the edges, less than 10 feet in most cases along the edges of the aquifer. You have a bit of a trough type, looks like probably some old river channels cut through the shale at one time. And you can see up there where the public water supply wells are. You can see that that's the deepest part of the aquifer, and that's a great place to be drawing water from. But the plan was to perhaps look to the west, and you can see how the aquifer thins dramatically to 30 feet and even 10 feet by the time you get over by Two Moon Bridge area. So again, you're in the deepest part over here, and there's less potential over here to the right side and the south parts of the aquifer. But we'll be defining this. This will help a great deal in defining that model. And so that, again, just wanted to point out that that's the prime source of water for most of the resort area, and it gets smaller and smaller each time you look at it, but there's still great capacity there, and we're just going to try and figure out what that capacity might be. And so Kirk is developing this groundwater model. And so we hope to tie in all this geologic information, the water quality information, the changing water levels, and then Ron's giving us access to the pumping rates and pumping schedules so that we can develop this model to simulate what's going on here. And then when you want to look at more development in this area, you can add wells to this system, you can change pumping rates, and the model should respond in a way that will help you predict what's going to go on in this aquifer and what its capacity and potential might actually be. So that's all. And Mike said he's got the snowboarding, and I just wanted to mention I'm about the job. So.